This lesson is about reliability of measurement and significant figures. Please take notes in your journal. Feel free to pause the presentation and rewind if you need to. When we are making measurements for chemistry, we're very interested to know how reliable are our measurements and to be able to express to the reader whether our numbers are very precise and with what degree of precision we make those. Let's talk about the difference between accuracy and precision. Accuracy is how close a measurement is to the actual or true value. If I stand on the scale and the bathroom scale tells me I weigh 600 pounds, well, for one, I'd probably break the scale, but also I know it wasn't giving me a true or accurate value. If you throw darts, you try to hit the bullseye, we say that's an accurate throw. Precision has a couple of different definitions. One of those definitions is how consistently a measurement is made, whether it's reproducible or not. If I put a nickel on the balance and it tells me the mass of the nickel is 5 grams, and I take the nickel off and I put it back on and it says 5 grams again, and I take it off and I put it back on and it still says the nickel is 5 grams, then that's a pretty reliable, not reliable, but a measurement that's been reproduced several times. So it's very consistent. And when you play darts, if you hit your darts all in the same section of the dartboard, that would be a precise grouping of throws. But precision also tells us things about the level of detail with which a quantity is measured. When I have the opportunity to demonstrate this in class, we'll look at some different measuring instruments like beakers versus graduated cylinders versus volumetric pipettes, or different kinds of balances we have that measure to different number of digits and therefore are different costs when we buy the balance. I can show you that. Precision tells us something about the level of detail with which the quantity is measured. It also reflects the number of digits, or the number of digits used to express the value tells us something about the precision. In general, more precise measurements have more significant digits. It's a more sensitive balance that can tell you the difference between something that weighs 1.136 grams or has a mass of that versus a balance that only says 1.1 gram. It's more detail. It's like when you have different kinds of monitors or screens that have different resolution. Greater resolution is more precision. Sometimes we will use a formula called percent error to express how far off our measurements are from a true or accepted value. And these are absolute value bars, and A is accepted true or correct value, where O is the observed or experimental value. Now notice that since these are in absolute value bars, it doesn't really matter whether it's O minus A or A minus O, because you get the difference and then you make it positive anyway. Some textbooks will prefer that you do it a specific way, then reflect error with a positive or a negative sign to express if your percentage error is too high or too low. But using absolute value just gives us an absolute error, and that's fine with me. Now we're going to talk a whole lot about significant figures. And I think since we're almost 4.5 minutes, I'm going to stop that and put it in a separate video for you. So stay